Welcome back, everybody. For today's lesson, we're going to start Unit 6. Unit 6 is the applications of probability. We're going to talk about probability in a future lesson, but in order to talk about probability, we need to understand a concept called sets. So that's what today's lesson is going to be on. It's going to be sets. Now, a set in math is a collection of distinct objects. So it's just a collection of objects. Now, the word distinct is important to throw in there because it means that none of the objects will repeat. Okay. Now, when we say objects, that's very generic. It can mean pretty much anything. Okay. So we can have names, we could have animals, we could have colors, we could have numbers. Anything can be an object in a set. So I'm going to create a set, and this is what a set looks like. So I'm going to call the set P. Okay, we usually use capital letters to name a set. So you can name a set whatever you want. I could call this A, I could call this B, I could call this C. I'm calling it P. Okay, and you'll see why in a second. But to write a set, when we're talking about a set, we use a symbol that's called a curly bracket. That looks like that. Okay, it's almost like a parentheses, but it has like a little break in between. Okay, so we use a curly bracket, and then we list out each of the objects in the set, and we separate them with a comma. So I use P because I'm going to write pet names. So we could have a dog, that's a type of pet. We could have a cat, fish, and hamster. And then I use a curly bracket at the end. So this is what a set would look like. You have curly brackets at the start and at the end, and you have each object separated with a comma. That's what a set looks like. Now, there's a special word that we use to talk about what is inside of a set. That word is called element. So an element is an object in a set. So in this example, dog, cat, fish, and hamster are all elements of the set P. So I called the set P. Each individual object is an element of P. If we talked about a different animal, for example, let's say a snake, snake is not an element of P because it's not in the set. Now, when we talk about sets, there is something called a subset. And a subset is a set that has elements that are also in another set. So it's a set that has elements that are also in another set. So if you have a set and all of the elements in that set are also in another set, then you say that first set is a subset of the second set. So for example, let's call this M. I'm calling my set M. Again, I could have called this whatever I wanted. I'm just using M. And I'm going to say this is the set containing the elements dog and cat. And that's it. So this only has two elements. It has dog and cat. Well, dog and cat are elements of M, but dog and cat are also elements of P. So everything in M is also in P. So that means M is a subset of P. Alright, at this point, I'm about to erase what I've written, so if you want to take a screenshot of the notes so that you have them saved, this would be a good time to take a screenshot of the notes. before I erase it and we go to the next thing. So just as a recap, we have sets, which is a collection of distinct objects. Okay, it could be any type of object. It could be words, it could be numbers, etc. We have elements, which are each of the individual objects in a set. And then we have a subset, which would be a set that every element is also in another set. So M would be a subset of P. Alright, the next thing we're going to talk about is special types of sets. And in particular, we're going to talk about a set called the empty set. Okay, now the empty set, you might already have an idea based on the name. The empty set is a set that has no elements. Okay, and there are two ways that we write the empty set. One way would be just to make a set that has nothing in it. So that would be, you have a bracket and there's nothing inside, so you just close the bracket. So it's just two brackets with nothing inside. That's one way to write the empty set. This is not as common as the other way. The more common way is to write the empty set is like a circle with a line through it. Okay, so this means empty set. It means there's nothing in that set. We will be looking at empty set in probability. Okay, and we'll get more into that when we get into probability. We'll talk a little bit about it at the end of this lesson, but we're going to go more deep into it in the next lesson. But this is the empty set. This is how you write it. If you see this symbol, that means the set has nothing in it. It's just a set with nothing. Okay, that may not make sense right now, but when we talk about probability, we'll talk about how the empty set comes into play. Okay, now another thing that we can do with sets is we can do some operations with sets. So if we had two sets, I'm going to go ahead and write out some examples of two sets, and we're going to do some things with these two sets. So I'm going to start with the set A. Okay, I'm just choosing random letters, it doesn't matter. And I'm going to say set A has the numbers 1, 2, 3, 4, 5. And I'm going to say the set B is the set with let's choose 2, 4, 6, and 8. Oops. So I have these two sets. One is the set 1, 2, 3, 4, 5. B is the set 2, 4, 6, 8. Now what we're going to be talking about are different operations that we can use with sets. The first two we're going to talk about are intersection and union. Alright, so intersection, if we're talking about the intersection of two sets, we're talking about what do the two sets have in common. Okay, so let me write that out. What do the two sets have in common? Okay, there are two ways that we write intersections. One is using a symbol and one is using words. You need to know both of these. So one way we could write it is A intersection B. So this one that looks like kind of like a capital N, and let me zoom in since we are, so you can see it a little bit better. Okay, let me move this so you can see it. Okay, so this symbol here that looks kind of like a capital N or like an upside down U means intersection. This is one way to write it. The other way to write it, okay, and let me not use that word, would be A and B. Okay, the word and goes with the word intersection. Now, it's kind of, there's a way to kind of remember this, and it has to do with the way that it sounds. Intersection has an N in it, intersection, so it looks like an N in the symbol, and also has that N sound in it. Intersection, and then an N. So you have to kind of think N, N, N. Now, when we're talking about the intersection of A and B, so intersection A, B, we could write it as a symbol or using the word and. We're talking about all of the elements that are both in A and also in B. So in this case, the ones that they have in common are 2. Both sets have the number 2. And 4. Both have the number 4. Every other number, 1, 3, 5, 6, and 8, only appear in one or the other. 2 and 4 are in both A and B. They are in both A and B. So the intersection of A and B would be the set 2, 4. Alright, 2, 4. That's the intersection of A and B. Now, one important note to take here is that the order that you write numbers, or the order that you write the elements in a set does not matter. I could have wrote 4, 2. Of here, I could have put these in any random order. It does not change the set. It does not matter. Okay? As long as each element is distinct, remember back to the definition, is that each element is distinct, which means none of them repeat. It doesn't matter the order. So I could have wrote 4, 2, and it means the exact same thing. Okay? Now that was the intersection of A and B. The other operation that we have is called union. Okay? Union. So a union is basically combining the two sets. So an union is combining the two sets. Just like if you have a union of two things, you're putting them together, you're uniting them together. So a union is a combining of the two sets. The way that we write this is, let me grab another color. Instead of this one's also kind of easy to remember. It looks like this, the symbol. It looks like a capital U, which makes sense because we're talking about union. So a capital U makes sense to be the symbol. Except there's no, like, you see how here when I write my U, it kind of comes down? There's none of that here. It's just the U shape. Okay, like don't put that there. Okay, it's not a capital U, it just looks like one. So A union B. Another way to write this is A or B. Okay, that means if the element is in A or B, it goes into the set. So in this case, the union of A and B would be the set. Well, if we look at this, 1 is 1 either in A or B? Yes, it's in A. So that means it goes into the set. Is 2 in A or B? Yes, it's in both of them, which means it's in one or the other. It's in both. That counts. So 1, 2, well, 3, 4, 5, 6, and 8. Basically, anything that shows up in either A or B goes into the set. So we're just combining the two sets together into one big set. That's union. So we've got intersection, which is what do they have in common? What do they have in common? And we have the union, which is combining them together. So those are two of the operations that we can do with sets. So again, like before, if you want to take a screenshot of the notes, go ahead and take a screenshot so that way you have these notes, and then I will erase them to go to the next portion of the lesson. So go ahead and take a screenshot. Alright, the last operation that we're going to talk about is called complement. So, let me write it out. Complement. Complement. Alright, I'm going to go back to the original example, so I'm going to rewrite it again. We had, well, let me use the same colors that I used before. We had P, which was the set containing dog, cat, fish, and hamster. And we had the set M, which was the subset that only had dog and cat. Okay, in case you're wondering, I use M because dogs and cats are mammals. Well, I guess technically hamster's a mammal too, so I didn't think that one through very well. But here we go. We've got these two sets. We've got P and M. Right? When we're talking about the complement of a set, we are talking about what is not in the set. What is not in the set? So the word not is the word that goes with complement. So intersection, the word was and. Union, the word was or. Complement, the word is not. So when we're talking about the complement of a set, we could talk about this set M, which is a subset of P. If we're talking about M, the way that we write complement is using an apostrophe. So we call this M prime. This goes back, we used this symbol back when we talked about transformations. If we translated something, the image was called whatever the original point was, prime. It's the same terminology. So M prime, which is the complement of M, means what is not in M? Well, the set of what is not in M, we have dog and cat in M, so what's not in M is fish and hamster. So the M complement would be fish and hamster. So that would be a complement. That's an example of a complement. It's what is not in the set. So in this case, dog and cat, well, dog and cat is a subset of the pets of P. M is a subset of P, so M prime is everything that's in P that is not in M. So dog and cat are in M, so we have fish and hamster, that's M prime. Okay, every time, and I'm going to go ahead and write this down, the union, okay, let me see, how would I write this? The union of a set and its complement really, I should say of a subset and its complement is the set. So in other words, for this one, if we took M, which was dog and cat, and we did union M prime, which was fish and hamster, the complement of M. Remember, union means anything that's in M or in M prime goes into the set. So if we were to take the union of these two, we just combine the two sets together. Well, M has dog and cat, and M prime has fish and hamster. So we're back to where we started. We're back to P. So M union M prime is P. So that's just one thing about the union of a subset and its complement. It makes up everything. So it's either going to be in the subset or it's either going to not be in it. It's never gonna. There's never gonna be anything left over. All right. Go ahead and take a screenshot of this because I'm going to erase it. And then I'm going to give you a couple more examples, and then I'm going to talk about one last thing before to finish the lesson. Alright, so go ahead and take a screenshot. Let me erase this now. So I'm going to give you some examples of some unions and intersections and all that. But to do that, we're going to put some context to it. So a lot of what we do in probability is going to have context, so I'm going to be doing these as with context. Now there's two things that we're going to talk about, okay? And again, we'll go more into detail with this when we get into probability, but I'm going to introduce it here, and then we'll come back to it when we get to the next lesson. So the first thing is called a sample space. Okay. Sample space is the set of all outcomes it's the set of all outcomes. Okay. So a sample space is the set of all outcomes. So when we're talking about probability, there's going to be a chance of something happening. Now, all of the possible outcomes that could come from whatever we're talking about, that's called the sample space. Okay, a lot of what we're going to be looking at is like people doing like surveys, like people who like sports versus people who like to read or whatever. This is just examples that I'm coming up with the top of my head. But anybody who could possibly be chosen is in the sample space. They're in the set of all outcomes. Then we have what's called an event, which is a subset of the sample space. So that could be, for example, let's say we're talking about everybody in one class. Let's say everybody in my second period, which I don't have a second period. Everybody in my second period would be in the sample space. An event would be, for example, the subset of all my students who are female. That would be an event. That's a subset of the sample space. Everybody in the class is in the sample space. Just the females would be a subset of that sample space. Okay? So, let's say we have a sample space. Okay? I will call it U. Okay, this is the letter U, not union. The sample space is the set. I'm going to call U is going to be my sample space, and it's going to be different sports. Okay, so U is going to represent sports. And I'm going to say soccer, that's my sport. Football. Hockey. Track. And let's throw in one more for good measure. Let's go with baseball. Actually, let's go with tennis. Sorry, baseball fans. Alright, so this is my sample space. Soccer, football, hockey, track, and tennis. Now, I'm going to create two different events. Okay, so event A will be, okay, actually let me write this out in words before we talk about the set. I'm going to say A is the event that a sport has a ball. A is the event that a sport has a ball. And then I'm going to say B is the event that a sport is a team sport. So, both of these are going to be subsets of the sample space. The set of A will be all of the sports that have a ball, that uses a ball. The B will be a subset that has all the sports that are team sports. So, if we look at the set of A, well, which of these sports uses a ball? Soccer uses a ball. Football, well, has the word ball in it. Football uses a ball. Hockey does not use a ball, it uses a puck. Track does not use a ball, and, well, I guess that would be track and field, but track itself does not use a ball. Tennis does use a ball. So soccer, football, and tennis would be, they would be elements, or they would be, elements of the subset. This is a subset because all of these elements are in the sample space. That's what makes this an event. So, talking about probability, kind of giving a little bit of a preview, we would say, we could talk about what are the chances, what are the chances that we pick a sport that has a ball? And then we could do probability that way. But we'll get more into that later. B is the event that sport is a team sport. So this would be the set of all the team sports. Well, soccer is a team sport. Football is a team sport. And hockey is a team sport. Okay, track and tennis are individual. I mean, you can have a team, but the actual competition is individual. Okay, you're not competing multiple people against multiple people. So we have the subset of team sports is soccer, football, and hockey. And we have the subset of sports that use a ball, soccer, football, tennis. Now we're going to find three different things. We're going to find a intersect B. Remember, the N means, or like it looks like an N, like an upside down U, means intersection. We're going to find a union B. Okay, remember, one that looks like a U is union. We're going to find A prime and B prime. These are the complements. Okay, if you need to look back at the notes, look back at your notes. But we're going to talk about them. So intersection is the ones that they have in common. It's A elements that are in A and B. So, and B. So which sports show up in A and also in B? Well, soccer and football are the only ones. So we have soccer and football. Okay, getting a little close here, I will move this over. So that would be it. Soccer's in A, soccer's in B. Football's in A, football's in B. Tennis is in A, tennis is not in B. It does not go into the intersection. Hockey is in B, but it's not in A. It does not go in the intersection. Okay. Union means or. So elements that are in A or B. So in other words, anything that shows up in either one goes into the set. So that's going to be soccer, football, tennis. Okay, I'm going to need to move these over again. And hockey. Soccer shows up in both of them, that's fine. Football shows up in both of them. Tennis shows up and hockey shows up, they go into the set. So this is A union B. It's everything that's in either one. Okay, and then we have the complements. So A prime is the complement of A. That's everything that's in the sample space that's not in A. So we have soccer, football, and tennis. Hockey and track are not in there. So that will be the complement of A. The two sports that did not show up in A, which was hockey and tennis. That's in the sample space, so it shows up in the complement. Hockey and tennis. And then for B prime, well, we have soccer, football, and hockey. So track and tennis did not show up, so that will be in the complement. Remember, complement means what's not in the set. Track and tennis. Alright, so I'll zoom this out so you can take a screenshot of it. You have all these notes. Take a screenshot of that. And that pretty much concludes the lesson for today. Okay, sorry it was a little bit of a longer one, but hopefully it will help you to do the quiz. So that being said, there is a quiz, so make sure that you go and take the quiz. Now, if you've made it this far in the video and you sat through all that and you paid attention, then I'm going to reward you, okay? And the last question on the quiz, I purposefully made it very confusing. It had nothing to do with what we talked about because I wanted to make sure to know who was paying attention and who watched the video. So for the last one on the quiz, okay, I'll write this on the board so you can see it, not just hear it. But the last question on the quiz the answer is this is N. Okay, it looks like a kind of like a capital N with like kind of fancy letter, but the answer is N. Okay, you don't even need to know what the question's asking. You don't need to know what it means, but the answer is N. Okay, so if you got this far in the video, congratulations, you got that question. Now, all the other questions we talked about here, if you need to go back and watch it again, go back and watch it again. Look at the screenshots that you took. That's fine. But good luck, and then that's all you have for today. So take the quiz over the notes, and then you're good.